back to 8.3. Talking about special right triangles. What's so special about them? A ver qué dicen. All right. So our first theorem here is 8.6, the 45-45 90-degree theorem. Now it's called 45-45 90-degree theorem because guess what? We have a 45-degree angle, another 45-degree angle, and the last but not least, the 90-degree angle. Now, as the theorem says, it says, hey, in a 45-45 90-degree triangle, the hypotenuse is radical 2 times longer than the legs. So on the 45-45 degree triangles, if the two angles are the same, as we said before, then the sides opposite of those angles are equal to each other as well. So if this side right here is 12, then this side right here is 12. That's a great thing about 45-45. So you already know one of the answers. But let's look at this part right here. It says that the value of the hypotenuse is radical 2 times more. So that's exactly what we're going to do. We're going to take the value of the leg and multiply it times radical 2. So whatever this leg is, I'm going to take it times radical 2. And see what we get. So 12 times radical 2 will give us this value right here. Well, 12 times radical 2 is just 12 radical 2. Like we talked about before, when you multiply whole numbers in radicals, they can't actually multiply. You just put them next to each other like that. All right. So, and it works at either leg. Because again, both legs are the same, and they both are going over here can go towards hypotenuse. So this 12 times radical 2 gives me a 12 radical 2, the longest side. But what about if we're going backwards? So what if we know that the hypotenuse is 8? So this is a 45, 45, 90-degree triangle. So let's say, hey, this is 8. It's the hypotenuse. If I want to know the legs, what would I do? Well, what's the opposite of multiplication? Yep, that is right. You are right. It is division. Yes, sir. Yes, sir. So what we're going to take, dividing by radical is a little bit different. So we're going to take the value of 8. Let's do that. Divide by radical 2. Now, similar to fractions, you can't have a radical in the denominator. So what we do is to get rid of it, we multiply the top and the bottom by another radical 2. Because technically, radical 2 over radical 2 is just 1. So the value of it doesn't change, just the way it looks. So on the top, 8 times radical 2 just gives me a radical 8 radical 2. But on the bottom, radical 2 times radical 2, as we practiced before, is radical 4. Now, radical 4, the reason we do that is because now we have a perfect square number. Square root of 4 is 2. So we get 8 radical 2 over 2. And then that just happens to reduce into that evenly, giving me the value, final answer is 4 radical 2. So that means both of these legs are 4 radical 2 and 4 radical 2. Now, another way to kind of think about this, some of you guys will get it, some of you guys won't, and that's okay. The value of the legs, especially if you're given a whole number here, if you're given a whole number, an easy way to remember this is we take the value of that whole number, divide it by 2, and then put a radical 2 in it. Okay, so let's kind of test that theory out, see if it's true. Let's take 10. Okay, I'm going to do this in a different color. Let's take 10. So this is a 45, 45, 90-degree triangle. So if I'm going to either one of the legs, I should divide that 10 in half, giving me 5, and then put a radical 2 in it. Okay, that's what the answer we should get. Let's test that out. So remember, we're dividing by a radical 2 this time. So 10 divided by radical 2, and like we said, you can't divide by radical 2, so you multiply the top and the bottom by radical 2s. We're given 10 radical 2 on top and a radical 4 on bottom. Square root of 4 is a whole number 2, so we got 10 radical 2 over 2. 2 goes into 10 5 times, giving me a 5 radical 2. Okay, so that's a quick way to kind of remember that. Now again, if you have a whole number on the legs, all you do is slap on a radical 2, and there's your hypotenuse on a 45, 45, 90-degree triangle. Okay, here's a couple more examples. So this is 9 radical 2, and this is 9 radical 2. Which of these three sides do we assume is the hypotenuse? The left, the right, or the top? The top. This would be the hypotenuse. Now, it may not look like a 90-degree angle right here, and it kind of doesn't. It still doesn't look like 45s, but that's the assumption we're going to go ahead and do. So, hey, 9 radical 2, 9 radical 2. So now to go again, to go from the leg to the hypotenuse, from leg to hypotenuse, you multiply by radical 2. So we have 9. Now, you ask, hey, there's already a radical 2 on there. What do we do with that? Well, 9 radical 2 times a radical 2. Just like before, you can multiply radicals with radicals. That gives us 9 radical 4. And radical 4 becomes a whole number 2. So we got 9 times 2, you get 18. All right, so now the longest side, which is pretty obviously the longest side, is a 5. So that means this is our 90 degrees. These are 45s right here. So again, to go from the hypotenuse to the legs, either one, we're going to divide by radical 2. Divide by radical 2. So let's do our little trick. We say, hey, we take the value of the whole number divided by 2. So 5 divided by 2 is 2.5. So you can leave it as a fraction, as 5 over 2, or 2.5. And then slap a radical 2 on there. So you can either have 2.5 radical 2 or 5 over 2 radical 2. Either one will be correct in this case. All right, so that's the first special right triangle. Let's look at the next one. The next one, we call it a 30, 60, 90 degree theorem. Take a wild guess why. You're right. It is a 30 degree, a 60 degree, and a 90 degree triangle or angle right there. So 30, 60, 90. So the theorem says the hypotenuse is twice as long as the smallest leg, and the longer leg is radical 3 times longer than the smallest leg. So everything here is kind of based off the smallest leg. So our goal is to always know what the smallest leg is. Okay. So according to this, the hypotenuse is twice the length of the smallest legs. So again, here we have a 30, 60, and 90. The hypotenuse is always across the 90. So this 13 they gave us, this is our hypotenuse. We need to figure out the smallest leg. The smallest leg is always across from the smallest angle. So if this is 30, this is the smallest side, smallest leg. The 60, this is our longer leg. So according to this, to go from the smallest leg to the hypotenuse, so the hypotenuse is twice the length of the smallest leg. So to go from the smallest leg to the hypotenuse, we had to multiply by 2. So if we're coming back, if we're going from the hypotenuse back to the smallest leg, what do you think we're going to do? Yeah, we're going to divide by 2 this time. So let's do that. Take 13 divided by 2. We get either, you can call it 13 over 2 or 6.5. I like the fraction better only because no decimals. All right, so we got our smallest leg. We're good. We'll go with the 6.5. Some of you guys enjoy that. Either one. We'll do both of them regardless. Now it says the longer leg is radical 3 times longer than the smallest leg. So we have the smallest leg, our 6.5 here. So to go from the smallest leg over to our longer leg, we're going to multiply. So radical 3 times means multiply by radical 3. Well, 6.5 times radical 3 is just 6.5 radical 3. Just like the radical 2, you kind of just slap it on there. Here you go. Got your radical 3. Or 13 over 2 radical 3. All right. So let's try this one again. This time they give us the smallest leg. The smallest leg is the 9. Okay. So here's our 90-degree angle. That means this is our hypotenuse. And this is the 60. Here's the opposite. So this is the longer leg. So again, like it says, the hypotenuse is twice the length of the smallest leg. So to go from the smallest leg to the hypotenuse, we multiply by 2. So we do that, we get 18. To go from the small leg, so small to hypotenuse. To go from the small leg to the long leg, so small to long. we multiply by radical 3. So 9 times radical 3 is 9 radical 3. Look at that. Saved us. We didn't have to do the Pythagorean theorem. We didn't have to square this and square root that. It's just there you go. Works out. That's what makes these triangles special, because this pattern will always work on these shapes, on these special triangles, this 45, 45, 90 degree, and the 30, 60, 90. Let's practice the 30, 60, 90 a little bit more. So here's one with, they give us the long leg. So 30, 60, 90 degree triangle. So that means this is our long leg. This is a small leg, small this. And this is our hypotenuse over here. Again, you cannot go from the long leg to the hypotenuse. There's no way. You have to come to the small leg and then take that value and double it to get the hypotenuse. Okay? Now, when we were going from small leg this way, we multiply by radical 3. So if we're going from here to here, what do you think we're doing? Yeah, we're going to divide by radical 3. So let's do that. So we'll take our 12 divided by radical 3. There we go. So just like before, you can't divide by a radical 3, so you're going to multiply both the top and the bottom by that radical 3. On the top, we're left with 12 radical 3 over radical 9. The square root of 9 is 3, so we got 12 radical 3 over 3. And this one just happens to go into 12, giving me 4 radical 3. So that's the length of this small side right here. Now, to go from the small side to the hypotenuse, now that we have the small side, we multiply by 2. Now again, this is the whole number 2. So the only thing this 2 can multiply to is the 4, giving us 8 radical 3. The radical 3 stays as it is because you cannot multiply a whole number 2 with a radical number. All right, last one of these right here. So again, this time, here's a 90, here's a 60, here's a 30. Some of you guys might ask, how do you know which one's 30, which one's 60? They make it kind of obvious. Either they'll tell you 30, 60, 90, or if you look right here, excuse me, this is a lot smaller than this. It's a lot smaller. And this length right here is way smaller than this length right here. It's kind of obvious looking, but can't, assumptions kind of a bad thing. So they either tell you or they'll give you enough information to make that assumption right there. So this time we have the hypotenuse. So that means we want the small leg, which we need to find first before we can find the long leg. You cannot go from here to here. You cannot do that. So we're going from hypotenuse to small leg. So we're going to divide by radical 3. So not radical 3, sorry. Told you guys wrong. Excuse me. So we're going to divide by 2, because again, to go from small leg to hypotenuse, you multiply by 2. So to go backwards, you divide by 2. So 15 divided by 2 is 7.5, or just 15 over 2. 4. So now we're going from small leg to long leg. That means this is a multiply by radical 3. So 7.5 times radical 3 is just 7.5 radical 3, or 15 over 2 radical 3. All right, all right. Last example on here. So we have an equilateral triangles with size 12. They want to know the area. Now remember, area of a triangle is equal to base times height divided by 2. Now it does tell us that all sides are 12. 12, 12, and 12. It's an equilateral. That's the great thing about equilateral. All sides are the same. But what's also special about equilateral is that all angles are the same. So what's the value of all 3 angles in a triangle whose sum is 180? Yeah, they're all 60. 60, 60, and 60. So we have our base. It's 12. So we got 12 times height divided by 2. We're missing our height, y'all. We're missing our height. We're missing the line that goes down here. So let's kind of draw our height. Thing about height of an equilateral triangle is that it splits this whole triangle in half. But not only is it splitting the triangle in half, it splits this angle in half, forming a 30, 60, 90-degree triangle. So again, in this case, our hypotenuse is now the 12. That means our short side, just only this part right here, we're going from hypotenuse to short side, we're going to divide by 2, giving us 6. That's important to know because now we can figure out our long leg, and which also happens to be our height. Okay, so to go again from short leg to long leg, we multiply by radical 3. So 6 times radical 3 is 6 radical 3. So then now we can substitute that in here. So we got 12 times 6 radical 3 over 2. Now again, you multiply whole number with whole number. 12 times 2 is 72 radical 3 over 2. Okay? And then the 2 can reduce to 73 to be 36 radical 3. And we're done. So it'll be units squared. That is our area right here, y'all. All right. Thanks for coming. Have a wonderful day.